To read the question, and y'all are going to listen and be respectful. Go ahead, Ashley.
Explain the law of conservation of mass. Discuss how it relates to mass relationships and chemical reactions.
Very good. All right, thank you. Let's talk about this. Let's go over an example of a chemical reaction that can happen. All right, what type of chemical reaction is this? One of the 5 types of chemical reactions. What type is it? Synthesis. Very good. Now, if I go to balance this equation, all right, Victoria, what could I put in for my coefficients to balance this? Very good. 2, 1, 2. Why is there a subscript of 2 by the chlorine but not by the sodium? What kind of element is this? It occurs in a pair.
Binary. Covalent.
So that it's not either. It's an element. So it's not an ionic or covalent compound. It's an element that occurs in pairs. Who said it? Somebody said it.
Diatomic.
Thank you, Jasmine, Caleb. Very good. It's a diatomic element. All right? That's review, but it's important. You're going to see it, okay? If you haven't noticed, chemistry is cumulative. Is anyone having trouble on tests because they don't understand some of the stuff we learned earlier? Okay? What kind of thing is this? Element or compound? Compound. What type of compound? Now, ionic or covalent? Metal? Non-metal. Right. Why is this not NaCl2? Many people still do not understand that. Swap and drop, kids. We used our oxidation numbers to swap and drop. So Na1, Cl1. That's all there is to it. Okay? Now, doing a little review as we try to answer question 1. Explain the law of conservation of mass. All right, now, we talked about this a while back. Let's say we have 100 grams of sodium given to us. Well, we may form 200 or 300 grams of this. We don't know yet without doing a stoichiometry problem how much of this we will form. But how many grams of just sodium are going to be on this side of the equation if we started with 100 grams of just sodium on the reactant side? How many grams of just sodium are we going to have to end up with? 100 grams of sodium if we start with 100 grams of sodium.
Wait, why don't you times it by that too?
That's a mole-to-mole thing, and we'll go through a problem where we deal with that in just a minute. All right, now back to the law of conservation of mass. Y'all know what that is. Who can raise their hand and tell me what that is? Aaron Crankshaw?
You have to have as much of it as you started with.
Yes, you have to have as much as, say it again.
You have to have as much of whatever it was when you started. So you can.
Yes, if we had 100 grams when we start, we have 100 grams when we finish. If we're talking about sodium in this case.
You cannot recreate nor destroy.
Very good. Matter or mass cannot be created nor destroyed. Right?
Unless acted upon by outside force.
Unless, unless. There is no unless.
I'm sorry. I was just having to think about it because.
Yeah, don't try to trip me when I'm taping. Caleb,
We learned about
Julian.
mistake.
All right.
Mistake in the time.
Now, how about looking at what Neely was saying? If we start with 2 moles of sodium, just talking about the element, then we will have how many moles of sodium in the product, kids? 2. So you can say the same thing about moles or mass, that we're not going to lose any, right? If we start with 100 grams worth of ham, and when we make our sandwiches, we're going to have 100 grams of worth of ham within the sandwich. All right? If we start with 100 slices of ham, we're going to have 100 slices of ham in our sandwiches. They may end up on the floor, or there may be some on the floor, there may be some in the sandwich, but together you're going to end up with 100 grams. After you get that, we're going to go on to numero dos.
Your cups are almost there.
Mm-hmm.
Where'd you get that? Laundry?
I like turning mine.
Hey, you're cutting napkins. And the highlighter.
Okay, who's ready for number 2?
Where's Chris? He's not here.
Where's Chris?
Oh yeah, his sister.
Number 2. Let's go with Caleb Julian. Read number 2. Caleb?
List at least 4 steps needed to solve a mass-to-mass stoichiometry calculation. Give an example to support your answer and explain the importance of each step.
Beautiful. Thank you, Caleb.
You're welcome.
Yes. All right. Everyone's doing a great job right now. All right. So,
Do we turn in this EQ sheet?
do we turn in the EQ sheet?
Before the test. Or
I should
after.
turn it in now.
Nope.
for a test
Not at
credit.
all. You take it on your test day, right, Jasmine? What's the reward for doing all this now?
You can use it on your test.
If you plug it into your head,
And then you can use
and then you can use what's in your head on the test.
That's
That's your reward, is that you know these questions are going to be on the test. I'm giving you the answers. Now, do I need you to tell me exactly that, or would I really rather have you rephrase it in your own words?
Friends in your words.
Tell you what you tell us to look at it.
No, because then I think that you wrote it on your hand and are using it during the test. I'd really rather you do your own thing. It's for Steph.
That's really bad for your skin.
Yes, it's not healthy. Okay. Now, we are going to do a mass-to-mass stoichiometry problem. Let me tell you this, guys. On your practice test, there are a lot of mass-to-mass problems. Okay? So now, let's use our example here. Right, Brian? All right. Let's say that we start with 100 grams of sodium, and we want to know how many grams of sodium chloride we can make. All right? Now, they're asking us to list the steps. So let's work a problem, and then we'll go back and list the steps. That's easier than trying to write it out in words. All right. Question. What are we looking for, Brian?
You're looking for grams.
Grams of what? NaCl. Shh, it's getting a little loud. I'm ready to send people in the hall. There's an empty spot with your name on it if you're talking. I know. All right. Shh. Let's go with Chan. What's the given info here on our problema? Yes, 100 grams of what? Sodium. What do I put that over? 1 mole, or 1 gram? 1. Very nice.
See, these are easy, but whenever you have to do the multiple ones,
We're about to do the multiple ones, and it's about to get nuts. Yes, we are, Chris. Yes, we are. Now, here we go, kids. This is it. It is mole map understanding time.
Okay.
All right?
Give us a second to get it out.
Take a second to get it out.
I don't got one.
You're gonna give this to Katie Kinch, the lovely girl in the front seat with the purple shirt. I'm listening. Excuse me. I posted it on Edmodo. Okay. Now, with the grams of sodium, look here. That's like my grams of, we'll call it substance A. Aren't we trying to find grams of something we're going to call substance B?
I have a question.
Yes.
Whenever you're looking at this mole map, how do you know which one is A and which one is B?
Whatever you start with is A, whatever you're looking for is B. And if you mix it up, it doesn't matter. You always go from whatever you started with to whatever you're looking for.
So what if you're given grams of B and you're trying to look for grams of A? Or can you not do
It's the
that?
same. It's a mirror image. No matter how you do it, you're going to get there. All right? So it's a foolproof method. All right, here we are. We have grams of A. Y'all see that right there? So what's my conversion factor here? Dwayne, what does that say in the purple? Molar mass. So what am I going to put down here, kids?
You're going to put grams of NA.
Grams of Na. Taylor Campbell, what do I put in front of moles of Na if it's a molar mass problem?
What, for grams?
Yes, always a 1, right? If it's a molar mass, I always put 1 in front of my mole. Okay, and then I look it up on the periodic table. So, Taylor, what is the molar mass of Na, sodium? 23, very good. You already figured that one out. All right?
But we're not going to.
We're not even close, but we did cancel out a unit, Victoria. And that gets us into moles of sodium. So now look where we are. We're now in moles of our given. What's my next conversion factor? Chris Albert. Mole to mole. Very good. So I'm going to go from moles of sodium to moles of what?
Sodium chloride. Sodium chloride.
Very good, Stephanie. Sodium chloride. That's what I'm looking for. Now, Kaylee, what do I use in front of my moles and moles in my mole to mole
Wait, I
ratio?
have a question.
Coefficients.
I have a question, Tom.
I'm ready?
So whenever you do mole to mole, you put what you're looking for at the top.
Yes. Yes. Because I'm trying to get from moles of what I have to moles of what I
So
want.
you always put what you're looking for at the top.
Yes. And also, what else does that do?
It cancels out.
It cancels out what you started with. Alrighty. Then we go from moles of this to grams of that. And is anyone feeling like we're about to pull in the driveway of our destination and get home safely?
Still got 33 minutes.
Where to get that?
That's what we got now, all the time. That's what Tom
Wait, Miss Mom, I have another question.
Screw it, got an iPhone.
Whenever you do that, whenever you do the molar mass,
Right on.
do you always put what you're looking for at the top and bottom?
Do I put what I'm looking for on top?
And the bottom?
Yes, but here, in this case, I'm going to put grams of what I'm looking for on the top and moles on the bottom because I want grams.
So you're using 2A.
Yes, ma'am. And then what unit cancels here? Mole. And I say, does everyone see the whole canceling of the units thing that's happening? Yes. Chris, what question do you have? 58.5. That is the mass of 23 plus 35.5. All right, is everyone behaving in a way that will help improve your grade, starting with tomorrow's big first test grade of the 9 weeks? All right, is everyone feeling good about at least that you're having the right behavior?
Is behavior gonna come into play in the grade?
Well, what do I mean by behavior? I don't just mean sitting up.
Sit and ISS.
Let's look at somebody like Caleb and Casey. All right? Now, they're looking ready to learn. They're not trying to distract anybody. But here's the key. Are you guys getting everything soaking in? And you're writing what you need down, okay? All right? Because you can look as beautiful as Casey or Caleb look, but you've got to be focused. If you're sitting there thinking about
Dogs.
taking your dog on a walk, going to your next pool party, that's not going to get you a stoichiometry grade test of a 100, is it? No.
Just looking like a 70.
No. All right, if all you think about is walking your dog this afternoon, that's not doing it for me, okay? Quick. Shh. Quick. Let's do math. Okay? Let's think about math for everyday life. Does everybody see the quick, easy math simplification that I can do? All right? That everybody needs to be able to do, not just chemistry people, right? Right. Jay Warner, take that stuff out of your ears, please. Okay? All right. Now, also, let's simplify. What is 100 divided by 23 kind of making you think about? That's an easy whole number. Isn't it like 100 divided by 25, which is equal to? 4. And what's 4 times about 60? It's about 240. So let's plug it into the calc and see what we get. Who's ready for that? All right, I already have 58.5 in here. What do I need to multiply that by that's also in the numerator? I'm going to go backwards, but that's okay, isn't it? Times 100. My goodness, I don't need to put that in the calculator, do I?
No.
Move your decimal 2 places to the right, and you got that made. Divide by 23. Yes, sirree. 254 G's. Is that close enough to our estimate? You can. But what if you were in a hurry and you forgot your calculator one day? What if you're at the store trying to figure something out on how much something might cost and you don't have your calculator with you? You can.
Hand it in your smartphone.
Yes, you can. But if you're not as fancy as us, then you can't do that. My goodness, doesn't this feel like a long answer to an essential question? What was the first step? What do we do here, kids? Write the given. Number 2. What's this fancy conversion factor called? Molar mass conversion. Casey, don't think about walking your dog or dancing in Chinese. Okay, next, do a mole to mole ratio to find moles of the needed substance. In this case, it was NaCl. How'd you spell it? Mol. Mollusk. You know what a mollusk is? Isn't that like a shrimp? Yeah. Did you know that was at my trivia bee last night? I'll tell you what, the honey, you know who is nicknamed the honey badger? The quarterback of LSU. Why? Why is that his nickname? I don't. What?
Is mass
Because he
in
doesn't
there?
care how big they are, he just attached just like an underdog.
Well, because molar mass conversion into the substance you're looking for.
Moles of needed substance.
And then we're done.